So let's go to page 4. No, sorry, page 2. Page 2. And first thing we need to review is the difference between probability and odds. And I know that you've seen that before in the younger grades, but I just want to give you a quick review on that. So on page 2, probability one thing you need to know is that the max can only be 100%. Max is 100% chance of something happening. We're not talking rate of return. Your rate of return for money can be 600%, 700%, 1,000. Anything like that can be more than 100. But probability, it has to be 100 max, right? So denominator is always greatest. How about we do that, and then we don't need to. Is the greatest. So if you do probability, and it's going to come to the point where you're going to try to come up with numbers, and the denominator is going to be smaller than the numerator, you should immediately think, wait a minute, something is wrong. Like, I'm not doing this right. And also, review here, if you want the probability of an event occurring, this might be rolling a 5, it could be picking a face card, this could be anything. You basically want to stack it like this, and you want the number of events that are possible over, this is the big distinction between probability and odds, is that you want the total events, right? So for drawing a face card, how many face cards are there? 12. In total, we've got 52, right? So that's what that would be. And then you've got probability of event not happening. So this is in general what probability, the way we're going to approach it is always trying to stack like that, okay? At the same time, there's a probability of that event not occurring. Not, okay? Then you would go, this is how I approach it. I go total minus the number of occurrences of that event over total. And here's some examples to wrap your head around this. Very simple. There are 7 red marbles, 3 green, and 5 blue. If I ask you, what's the probability of drawing a red marble? You should immediately know, oh, there are 7 possible reds, right? Divided by total, right? So immediately I want you to somewhere on that paper figure out the total. 7 and 3 is 10 plus 5 is 15, right? There's 15 in total, so that is imperative for probability. You figure out your total, your universal. Think of the universal set, right? 15. We could also state the same answer as a decimal. So here's where it gets a little nuanced, okay? Let's figure out what 7 over 15 is. This is where if you want full marks, this is where you need to pay attention. Okay? So you can write 0. If you round this to 2 decimals, what would you say? It'd be 4, 7, right? If you want to answer as a percentage, it would be wrong to say 47%. You round it incorrectly. So if you want to state it as a decimal, you round to 2 decimals. If you want to state it as a percentage, you got to take what you have on your calculator, multiply that by 100, and then round to 2 decimals. And this is why, because when you go 7 divided by 15, that's 0.4666, and that keeps going. Okay? So if you answer as a decimal, you just truncate it, right? You round it, and we have to round up, so that's why it's 0.47. If you want to state it as a percentage, we take this, we multiply that by 100, and once we've multiplied by 100, that's when we round to 2 decimals. So that's the nuance that you need to be aware of. Saying 47% would be wrong in that case. At the same time, what if I asked you, what's the probability against red, against picking a red one? Guess what? We're still talking about the same universal, 15. Against red, how many do we have that are not red? Yeah. Yeah, like the little tick here? Yeah, that's fine. So here you could say, well, I have the probability of in favor, like I know how many events are in favor, so you could just go total minus the reds, right? And then you get 8 out of 15. That's one way of doing it. Some of you are looking at this and you're like, wait a minute, Mr. Erickson, couldn't I just, I see that it's 3 and 5 is 8. Like there are 8 that are non-red. Can I do it that way? Absolutely. So it depends on how much information is given to you. So what would this be? Probability, you know what? I need to make a note. Can we go up here? It's not or against. Sometimes the question will say, what's the probability against that event? So if you see a red with a bar on top or a tick, it's probability against that. Okay. So probability against red would be, if this is, you could go 1 minus 0.47. And I'm just making these numbers up, so that'd be 0.53. Or probability against red, if you're talking percentage, you would want to go 100 minus 46.67. 53.33%. So that's how probability works. By the way, if I asked you, what would these two add up to? It happening and something not happening always amounts to 100%. Or 1, right? If you add the decimals, it adds up to 1. So that's something to remember as well. Okay? That's it for now. To be continued. Okay, now we're going to talk odds. When you do odds, make a note, never includes total. That is extremely important because students put the total in odds all of the time, okay? So if it says odds in favor, if you have the words in favor, let's go with red. first, before we do numbers, I'll do words first. If you see in favor, like this is important, in favor of what? Of red, that means that we're going to compare the red events against all the events that are not red. If you see odds against red, emphasis on against, it's just going to be flipped. So instead of going red, not red, if it says odds against red, you go not red first, and then you compare it to the amount of red events. I think that this is probably, if you want to include the example that I'm about to provide, you go for it. But this is probably a good summary of how we work with odds. What's been the last time you've seen probability and odds? Would you say junior high? Probably. Okay. Okay, so let's do this. If we have, let's go back to example 7 red, 3 green, 5 blue marbles. Again, total is 15. What if I said, figure out the odds in favor of red? I'm just going to stick with red for now. Because of the words in favor, by the way, guys, there's no such thing as the odds. It will be odds in favor and odds for. It has to be followed up with what's happening. Is it in favor or is it against? Is it for or is it against? Okay? If it's in favor of red, you should immediately know it's red compared to not red. Let's follow this up. What if this had said odds in favor of face card, of drawing a face card? Then we would go, well, we want all the faces first, and this would be all the cards that are non-face cards, right? So let's figure that out. So this would be 7 compared to, how many are not red? It'd be 8, right? And I want you to make a note that it's a total of 15. So the total is not in it, but you should always be able to add them up and get your total. Okay? Odds against red, against grabbing a red, would be you go not first, then you go red second. And essentially, I don't know why, but for me, it's always easier to focus on the event. So I'll put the 7 here. Not red. I know there's 8 of them. I get that, right? So notice the order matters. Okay. Total of 15. Okay, so odds and probability. So I'm going to pause here. Let me see. To get your feet wet, I will ask you to try page 5.
Excuse the interruption. There's a gray Nissan Altima parked in.
If you need a reminder, deck of cards here is one more time. You know what? I'll do it on a sticky note so I can take it with me. Okay? So we've got 26 red, 26 black. We've got 13 hearts, 13 diamonds, 13 spade, and 13 clubs. Every single of the 4 suits has ace, 2 to 10, jack, queen, king. Every single one of them. Ace, 2 to 10, jack, queen, king. Ace, 2 to 10, jack, queen, king. You should make sure that you have there's 12 face cards. There are 4 aces. There are numbered cards. How many numbered cards are there? Anybody remember? 52 in total. Take away the 4 aces, you're down to 48. Take away the 12 faces, so you're down to 36 numbered cards. Okay, try that. Try filling that in, and then we'll do odds later. Copy that down. You want me to go over a few probabilities first? I'll go over a few probabilities before we do the odds, okay? So that we know we're on the right. Okay. Oh, yeah. Oh. I will just do this Okay. We ready? So very important, very important. We're only rolling 1 die, correct? That's going to change soon. We'll have 2 die. So if it's a 6-sided, our total is always 6. So every single question here should be out of 6. Okay, every single one. So probability of rolling a 2, there's only one number 2 on a 6-sided die. Probability of rolling an even, how many evens do we have? Like this is 1, 2, 3, 4, 5, 6. There's 3 even numbers. Okay, so this would be 3 out of 6. You don't have to reduce fractions. Yay, right? I'll let you do the decimal part. Probability of rolling a number that's divisible by 3. How do you know something is divisible by 3? Right? It's 3, 6, 9, 12, and so forth. So it's just 3, 6. Those are the only 2 that are divisible by 3. You know what? I still need you to know how to simplify fractions just in case, because it could be a multiple choice question. So that's the only reason why. Do you remember how to do that on your calculator? Okay, I'll show you here real quick. These are going to be in the thousands down the road. Okay, these numbers are going to get really, really big. So if you go 3 divided by 6, and then go math and select fraction, it will reduce it for you, okay? So if you want to practice that, that's probably a good, habit, right? So 2 divided by 6, let's say, math, fraction, that's 1/3, okay? So sometimes there's a multiple choice question where the province says, hey, which one of these 4 is the right answer? That's the only time I would expect you to know how to simplify. Other than that, I don't care. Okay, this is important, okay? Make sure you listen. I don't want you to miss a question because of fractions. What is the last resort? If you don't know the answer, it's like, I don't know which one of these fractions is the right answer. Turn everything into a decimal. Turn all the options they give you into a decimal, turn whatever you got into a decimal, and then just check the one that matches, right? So please don't let fractions throw you off. Prime numbers, prime would be 2, 3, 5, 7, 11, and so forth. That's what we call prime, okay? So there'll be 2, 3, 5. There'll be 3 out of 6, so that's 1/2, right? Less than 5, probability of something less than 5. The classic is, Mr. Dixon, is 5 included? And I'll just stare at you, just read it out loud. Less than 5. So 1, 2, 3, 4, right? So it's 4 out of 6, that's 2/3. Greater than 6, what's up with that? There's nothing greater than 6 in our scenario here, so it's just 0. 0%, no chance of that happening. Greater or equal to 3, that means 3 is included, so that'd be 3, 4, 5, 6, right? 3, 4, 5, 6. So we've got 4 out of 6, which is 2/3. Okay? Deck of cards now. One is not a prime. So the definition of prime is, I know it's actually a very common mistake. So 1 is not it. So it's numbers that can be divisible by itself and 1, but 1 doesn't count, it starts at 2. So I know it's like, oh wait, 1 meets the criteria, it's divisible by 1 and itself, but 1 is not a prime. So it starts at 2. All right. Given a standard deck of cards, here, I'm going to do this here. Probability of an ace. So because it's a standard deck of cards, 52 is my total, for sure. So 52. What's the probability of drawing an ace? I look at my cheat sheet here. I've got 4 aces. Okay, 4. Probability of a club. Clubs, how many clubs do you have? There are 13 clubs, like 13. So this would be 13 out of 52. Ace of club, what's up with that? Ace of club, that means that only this one ace here, this is the only ace that is also a club. So it'd be 1/52. I will do the decimals and the percentages for these ones because they're small. Watch this, please. What I tend to do to get past the whole rounding issue, this is what I do, watch. I go 1 divided by 52, I go comma, don't go equals, 0.0192. Like I'll state my decimal in 4 places, and then I just shift the decimal over 2 places to get the percentage. Then it's very easy to see. Oh, that's why you put 1.92, because I show the first 4 digits after the decimal. It doesn't hurt. But Mr. Dixon, what if I round it to 2 decimal? What if I rounded this number to 2 decimals? Shouldn't I go 0.02? Yes, you are right. If you choose to round at 2 decimals, you have to round correctly. I choose to round to 4 decimals. As long as you round correctly, you're fine. And the reason I'm doing that is that it's easy to see how I got the percentage. Unless it's money, money is the only one that you have to round to 2 decimals. Everything else, 2 is the minimum. You can do more if you'd like. Okay. Greater than 6, what's up with that? That'll be 7, 8, 9, 10. Jack, Queen, King. So 1, 2, 3, 4, 5, 6, 7. Right? So I'll just multiply. I'll go 4 times 7. That's 28 out of 52. Red Queen, 52. There are 4 queens, except for at home. I only have 1 queen at home. 4 queens. How many reds? 2. I always use that joke, by the way. It's not a joke. It's actually true. 0.0385. That's 3.85%. So when it gets to small values, right, that's okay. It's okay to have 0.0. When it's really, really small, I always go to percent. Okay. Probability of red, can we all just agree that it's half? 26 out of 52. Not phase, okay, here you have to be careful. What is that saying? Not phase. So this is what I do. I know it's out of 52, right? I'm going to go 52 minus the 12 face cards. That's 40 out of 52. That's what when it's not, I focus on the event, I subtract it from the total. Picking a jack, there are 4 of them. Not jack, I will go 52 minus 4 over 52. That's 48 over 52. Make sure you pay attention. Red face card. How many faces are there? 12. When it comes to color, right, it's always half of what you have in total. So this would be 6. Yeah, 6. Let's turn that into, let's reduce that one just for fun. That'd be 3 over 26. Okay, so there you have it. You want to try the odds? You want me to do odds? Me to do odds? I have to do all the work, guys. I don't mind. Like if you're interested, I can talk all day, right? I just want you to have a chance to practice. So how about I do a couple and I'll maybe let go a little bit, okay? It's scary times, right? I'll let go of your hand. State the odds in favor of rolling even. So that means that I want even and not even. How many evens do you have? 3. And how many are not even? 3. You can treat this just like a fraction. You can divide both by the same number. So if you want 1 to 1, that is fine. Okay. Either one is fine. It's up to you. Odds against rolling a 5, that is basically saying rolling a, this is tricky here. Not rolling 5 comes first, and then rolling a 5 comes next. So how many 5s can you roll? 1. How many of them are not 5s? This is it's like a tongue twister. This one is you have to really pay attention what you're doing here. So add them up, what do you get? 6. Add this one up, what do you get? 2. Oops, what happened there, right? But if you go back to your work, you get to your 6 there. Okay. In favor of rolling a number greater than 3, I'm going to say in G3, and this is not G3. So how many numbers are greater than 3? 4, 5, 6. And therefore 3 are less than 3, or are not greater than 3. In favor of drawing an ace, if it says in favor, first of all, guys, I forgot to emphasize, if it's odds, you have to have the colon, okay? You have to have it. Please don't do fractions when it's odds. And then ask yourself, in favor or against? What are we talking about? In favor, that means that I want ace first, and all the ones that are not aces on the other side. Yes? Yeah. So how many aces do we have? 4? How many are non-ace? 48, right? How did you get that number? I would like to say 52 minus 4. You can reduce that to 1 to 4 if you divide both of them by 4. What about, I'm trying to make a point here, against face, right? So you, first of all, you notice it's odds. If it's against face, put the face here and not face over here. Make sure you do that in that order. And guess what I'm going to start with? I'm going to start with the face. That's 12. And here I'm going to start doing, I'm going to start showing my work as follows. I'm going to say that I have 12 faces, and here, this is going to give me the non-face cards. So that's 40 to 12, okay? There you go. All right. I'm going to stop there.